Chapter 5, Lesson 1 of Advanced Algebra, a quick video on quadratic modeling. So we looked at quadratic functions, the standard form. We looked at what the shape of the graph is, and now we want to apply that model to real-world data. And again, this is from earlier in the year. We talked about one of the things we'll be doing all year long is taking these new functions that we're learning and then applying them to data from real-world situations. So I'm looking at page 240, and there's a little example in there about time going by and then the water level in a jug or a bottle of water. And this would be an example of how you would use a quadratic to model a real-world situation. So remember we did earlier in this year, we talked about creating a scatter plot. So on the x-axis, you're going to have the time, and on the y-axis, you'll have the water level. You create that scatter plot, then we're looking for that line of best fit, remember, which is called a regression line. And so we would draw in there the line that we think fits the data the best, and then we would calculate the equation of that curve. And again, doing this by hand, we don't need to do that any longer because we have calculators that can help us do that. So you're going to use your calculator to help you do that. And then once you have that equation, you can then use that equation to model, or excuse me, to analyze or predict what might happen in the future if the numbers were a little bit different. So you can substitute in an x value into our model and then determine the y value, or vice versa. So I'm going to do a quick review of how you do that on your calculator. So I'm going to do it on my calculator, which is a little bit different, but I'll talk you through some of the examples and how you would have to do it on yours. Okay, so you remember to enter in the data first. You select the stat key on your calculator, and then you go to the edit, the edit selection, and that will bring you to the place where you have your table. So you enter in your lists of data. Remember, in one list you'll put your x values. I have here time, and then in the next list you'll put in your water or your y values. Now that you have the data in your table, you need to calculate the regression line, or the line of best fit. So you're going to select the stat key again, and then you're going to scroll over to the calc menu, and it should give you a number of different options, something that looks similar to this, where you have these different selections. Now we're dealing with quadratics, so we want to calculate the quadratic regression. So you'll go down and select that particular regression. Then again, it will ask you if you have the newer version, it will already have the X list there as L1, the Y list as L2. If you have the older operating system, it will go back to the main screen. You'll have to then enter in where your data is located. So you'll do the second key in 1, and right above that number 1 key on your calculator, you'll see L1, that will be list 1, and then comma, and then put your list 2, or where your Y values are located. So I have my X list are in list A, so I'm going to do that. My Y lists are in list B, and then it's going to save my equation into column 3, but don't worry about that, that's a little bit different. So you should have that, and then you go ahead and select enter, and then what it will give you is give you the quadratic regression. So you notice I have here, they have the quadratic regression. Below that, they'll have the equation, the standard form, ax squared plus bx plus c, and then it will give you the a value, which in this case is 0.009167, and then it will give you the b value, negative 2.10357, and then it will give you the c value all listed. So those are the numbers that you will put in for those letters, and then you will have your quadratic equation, or the equation of the line that best fits the data that we have. Y equals 0.009167 x squared, that's the a that I got from my regression calculation, minus 2.10x, that's the b from the calculation, plus 120, that's the c. So this is the quadratic regression, or the equation that best fits the data. Now in this case, remember, x was equal to the time passed, and y is equal to the water volume, I believe, right? Water, yeah, the water level. Excuse me, I forgot that was. And so now, if you give me a time value, let's say 20 seconds, because this is measured in seconds, 20 seconds, I could put 20 in for x and figure out what the water level would be. Or if you gave me a water level, say 12 12 millimeters, then I could tell you how much time it took by solving for x to figure out or to determine how much time went by in order to reach that level of water. So the model allows us to then predict and to analyze different values for x and y as we go through. So that's the power of applying this to real-world data. So remember how to do that, and again, we'll be doing the quadratic regressions throughout this lesson.